Can you see the screen now?
Yes.
Great. So what is the agenda today? We are going to learn about Docker learning means we will go through some ideas, some exchange of ideas over what do we mean by containerization, why is containerization so important, and what is the technology that is brought with Docker for containerization. These are the few things that we need to learn, and we will end up with seeing some hands-on. Okay, so that will give a better overview of what we are talking about. Let us start the thing. I will not go into too much of details of Docker because that we actually do in our main course. Okay. So before we learn about Docker, we should know what is container. And also, we cannot complete the discussion of container without understanding the images. An image and container both are software pieces of software, but container is an object which holds the image. An image is an object which holds which is an application, a software application like a Java application or a web application or any application, or Oracle application or a database application. Okay. So I will say that my image or my application will be contained within the container. Why? Why is this arrangement? And that is what we are going to learn today. So a container is a standard unit of software that packages up the code. The code is the application. Okay. And all its dependencies. So all the environment that needs to support the code will also be packaged under the container within the container. So the application runs quickly, and that is our objective, because we want to run the application as a single unit without any dependency on other things. In the entire environment is packaged within it, and therefore it will quickly and reliably run in the computing environment. So the code is nothing but the image, and that image is nothing but a static object unless and until you put that image into a container that you say you have containerized the image. You will not be able to run the image or run the application. And that image will be run by a Docker engine, basically the container. So once you put the image into a container, you have made two things into one, two in one. They are inseparable. Now they become a single joint, one engine, and that application inside the container will be run by the Docker engine. So this is available for both Linux and Windows-based applications, and even for Mac. When I say Mac, when I say Linux, I am also meaning Mac, because Mac is just a copy of your Linux kernel. So they should be running the same thing. This is a fantastic image to understand the container. You see, these are thin writable layers. The containers are nothing but, the containers, the ship. You have seen a ship, and you will see on a cargo ship, there will be lots of, it is carrying a lot of containers. And within the container, you will have your items that will be shipped from one port to the other port, from one country to the other country. Like it transports all the things. Like it could be food items, or it could be electronic items, whatever. That should be put inside the container, and the container moves along with the ship. So my ship is the Docker engine. Okay, got it? My ship is my Docker engine. And the container is the containers which are on the top deck of the ship. And then what is the image? The image is the item within the container. If you can have an analogy like that, it will be very easy for you to understand. Let's say this is the container. This box is the container. What is a container? Container is a object which can hold something, isn't it? So the green layer that you can see is the internal environment of the container. And that is called, we are calling it as boot FS, boot file system. And that whenever a Docker engine will create a container from the image, what will happen? It will create an internal environment. The internal environment will have the namespaces. That is, it will divide the entire space into some namespaces, okay, for segregation of the environment. And you have the C groups. C groups are the managers. The C group is called the manager, and you have the kernel. So basically, through the C groups, the kernel will manage the resources. The kernel is an internal environment of the container. Now, having understood that, so whatever isolation you need, that isolation will be enabled through namespaces. You want to manage the resources. Resources could be anything like the devices, the printer, the whatever you want to do. So that will be managed through the C groups. And finally, you come to the various layers of images. So I will say this is one image. Maybe the base image is Ubuntu. Then you have added Emacs. And then you have added Apache. Added means you have installed. On top of Ubuntu, you have installed. I will show you one example today where I will build an image out of the base image. And this base image, I will do it from my, the base image, I will do it from my, your Docker Hub. The Docker Hub is a repository, registry where you store all the images, all the official images, even your personal images. Images means the Docker images, not your photo, not a very good scenery. No such photos. It is the application images that you build and you can store it over the Docker Hub. So base image, this is the official version of Ubuntu Lightweight, and that I can put it over here. I can make this available into my container as the base image. And on the top of the base image, I will install, I can install Apache, Java application or Java compiler and all the stuff. But what I say is one container will be one image. So this plus this plus this will make one image. Yes, you can say these are the various layers. That's okay. Now, so the image is Docker image versus Docker container. So what you see, this is a Docker image. And you can put that image into multiple containers. So let's say you have created 3 containers out of the single image, and that is possible. But you cannot have 2 containers of the same name, or rather this image cannot be shared, or you cannot have a part of this image over here and part of this image over here. No, the entire Docker image will be that image will be over either here or there or there, or maybe in all 3 of them. And once you put this image into a container, so if the image is of 1 GB, here it is wrong. It will be a bit more than 1 GB. Why? Because you have this particular, this will occupy a bit of space as well. So maybe 1.1 GB if the Docker image is 1 GB. Any questions? It should not be a one-way traffic. You must ask any questions that might come into your mind immediately. That Devashish, um, then what is the difference between an image and a container? Yeah, they are two different objects. Totally two different objects. This is a static object, but this static object, which is an image, will not have any impact, or it will not have any existence without you put it inside a container. Once you put that image into a container, it becomes dynamic. It was static because now you can run that application as as an image within the container. But without the container, you cannot run it. So let's say this is a Java application, which is you have built as an image, and you will deploy it over into a container. You will put that into a container. That is called containerization. That is a very important term. Now, previous, I will not go into much of, because it is a this technology has become almost like backdated technology. Virtualization is still used, but most of the organizations have shifted over to containerization because the world is moving towards microservices. You could have virtualized. Basically, you are virtualizing your machine, your hardware into three different. So you have a big elephant like IBM AIX server. Okay. Now you cannot use the single big server for only one application. Can you? Then it's a total waste of your entire your resources. So what they have done, they will install hypervisor from the from Microsoft. It's a sort of virtual. This will enable the virtualization. This is a software. You install it over operating system, and with the help of this hypervisor, it can be VMware as well from Oracle or VirtualBox, anything. So on top of that, if you basically you are partitioning the entire hardware into three separate virtual machines. But this virtual machine will have the full version of the OS. Without an OS, you will not be able to create a virtual machine. Yeah, on top of it, you can have a Java application. This can be a .NET application of Microsoft. It can be a C++ application. So you are running three full versions of the application because you have all the full version of the operating system. Basically, then. But can you partition it further and further and further? Yes, you can do it, but it will be restricted because this with the guest OS you have to have the guest OS, which is the full version of this. You are occupying most of this application becomes too big. Let's say this is 2 GB, this is 1 GB, this is 3 GB. Okay. And your machine capacity is let's say 10 GB. So 2 GB plus 3 GB plus 1 GB. So how much it is? 6 GB. How much is left? 4 GB. So how many applications can you another virtualize? If you have another 2 GB applications, so maximum you can go another for 2 virtual machines. Then you will all occupy the entire 10 GB of memory. Okay. So that is the hardware restriction. Now we come to the containerization. I am using the same hardware and on top of it the same operating system. Okay, but instead of hypervisor, I have a installed Docker, or you can say any container engine. Follow? So what will it do? This is the beauty of container engine like Docker. What will it do? It will have, let's say we are having the same three applications, Java, .NET, and this was, I said, C++. But do you see any OS? Do you find any OS? No, you only need the requisite binaries and libraries to support the application. That's all. So if this was 2 GB, this will be around 30 MBs. So was that not a almost 6 times you are saving onto the not only 6 times, it will be 60 times you have reduced the size of the application. The same application now it is only occupying 30 MB, whereas this was occupying 2 GB, this was occupying 1 GB, this was occupying 3 GB. So 30 and maybe 20 and this may be 40, but not than that, not more than that. So can you think that the same 10 GB hard disk or 10 GB hardware now can be partitioned or not partitioned, containerized? You can have many more containers. And that is the beauty that you can have in your system more than because in your microservices, you need there will be hundreds and hundreds of microservices running, and those microservices has to be containerized inside a container. Okay, so that is containerization. It is, you can go through them. This again, I will tell you, if you are registered, you can go to our site and you will find the entire content of all these sessions. So this PPT will be also available over there. Now, just the same thing, it is a revolution in the application deployment. Earlier, it was through the virtual machines, which is called virtualization. Here, you are also doing a virtualization, but this is the virtualization of the OS. Here, you are not virtualizing the OS. You have to install the OS in every of the virtual machine. Whereas here, you do not see the OS at all. You have the infrastructure, you have the host operating system, you have the Docker engine, and therefore you can just extract only because this is one container. So this container is a self-sustained environment where you do not need any operating system to be supporting the environment. The environment is already built. You have the application and the requisite binaries and libraries. That's all. So what effects has this difference? This is the very famous logo of Docker. You know, there is a whale and the whale is containing the container. Do you know the history of Docker? Why it was named? It was initially, the project was called Moby project. Did you ever hear the movie, the Hollywood movie Moby Dick? Anyone have ever heard let's forget that I'm sure you have not seen the movie. I have seen the movie. It was a fantastic movie. And Gregory Peck was the main actor. He was the captain of the ship. Okay. So anybody have ever heard of this movie, Moby Dick? There was a famous story. It's a story. On the Pacific Ocean, there was a point where the ships used to get lost. I mean, they lose their track. They will divert some scientific reason, or the reason was not very known. But for some reason, the ships got lost at that point once it arrived at that point of the Pacific Ocean. So what will happen is it can take days for the captain to navigate the ship to the correct track. Suddenly, what happened is that particular captain saw, and the ship was at that point, okay, where it generally get lost. The captain was a bit under a tremendous pressure. It was trying all its measures to just navigate the path, the treacherous route. Suddenly he saw a white whale, okay, coming in the way. And then he thought maybe that is going to again, so the ship is in distress, and the whale is going to make it further in danger. But suddenly he found that the whale is guiding the ship. And in no time, the captain saw that he has not lost his way. The whale was, he could follow the whale, and the whale has taken it, uh, waded through that particular treacherous track and found the right track for the ship. So that was a friendly whale. So the project was named after Moby, because and the captain found that every time he took a ship with the same track in Pacific Ocean, there will be the white whale guiding all the ships to the right track. So it was a friend. Therefore, the project was named after Moby. Moby is the white whale, and that was the beginning of Docker. And you see the whale carrying the containers. That means is a friendly whale, and this is a symbol of the logo of Docker. Okay, so here the Docker, and here is the virtual machine, the virtualization. Docker images is couple of MB, whereas virtual machine images are couple of GB. It's a huge difference in terms of computer resources. This is a tremendous difference. Okay, containers take seconds to start. Because it is a very lightweight. Whatever the images that you put inside the containers are very lightweight. So it will just take a few seconds to start the container. Whereas because VMs are having the OS, you have to bootstrap the OS, and it can take an application to start only will take a few minutes. So can you understand the difference when it takes few seconds, whereas this is taking few minutes? Okay. And this is not right. At the time when I was writing this particular PowerPoint presentation, at that time, Docker was not available for everywhere. It was only available with Linux. But nowadays, Docker is available and compatible with not only with Linux, it is available with Windows and Mac. VM was always compatible with all the OS from the very beginning. So that is the comparison. You see, you have application A, B, C. So let's say this is Java application on top of a web server, Apache Tomcat. But this is one container. You are having two layers of images, but this is one image. So one container, one image. I will say that this is a Java web application image inside one container. Here also we will have a .NET application over an SQL Server database from Microsoft. There also we will see a Python application on top of MySQL database. So these are three different containers, and they are not dependent on each other. They are isolated. They are free. Clear? Do you have anywhere the mention of OS, either Ubuntu or Red Hat or Windows or Mac? No, not needed. These containers are very lightweight. Any question up to this point, please let me know. Hello. Any questions that you might have at this point? Or shall I continue with your approval? Okay, so let me go to the next slide. Oh, so what was the development process before we have the containerization? And what was the deployment process before the containers? So before we have containers, each developer needs to install and configure all services directly on their OS on their local machine. So a developer has to install everything. Nothing is ready-made, was not available like readily. So you have to do installation process different for each environment, OS environment. Now you have Mac, you have Red Hat, you have Ubuntu, Linux. Even with Linux, you have lots of varieties, lots of flavors. But for each of these flavors, you need to have an different installation process. So the installation process on Ubuntu will be a bit different from the installation process on Red Hat Linux. The installation process on Windows will be different from installation process on Mac. So that was a big headache. And you have to have many steps when something can go wrong. You have to rectify them. If something goes wrong, you have to make the entire system down, rectify it, put it back, do the regression testing, do the functional testing, everything is fine, then only you make the system up. So it is not very simple. Okay, you have Postgres SQL, which is a database, and Redis, let's say version 7. Both will have a different installation steps and configuration steps different. Let's say this is a Apple machine, Mac, and this is, let's say, a Red Hat machine. So they will have totally two different installation steps and configuration process. And what about the deployment? See, this is for the development. What about the deployment? Now you have developed something. You want to deploy it to the operations, because operations are the guys who will maintain the production server or the pre-production server or the testing server or the development server. So you have to deploy it, your application. So you are basically giving the environment along with the developed code to the operations to install over here. Let's say this is a jar file. Jar file, Java application archive file. Okay, so that Java jar file now needs to be ported onto a server in pre-production or production. So the artifacts and instructions are handed over to the operations team. Sorry. See, they are experts. They know how to tune the environment and do the installation, do the configuration. But what about the operations guys? They are poor guys. They do not know much. Yeah, they may be knowledgeable, but as far the development nitty-gritties are concerned, they might not know all the details. So they are given, the development guys will be giving the artifacts. Artifacts means documents and instruction manuals to the operating system. Do you think just by following the instruction manual, they will be able to tune the configuration, to configure the environment? They will fail a lot of time. There will be a lot of back and forth, and it will eat up a lot of time in the project. And finally, they will end up getting frustrated. They are not being able to somehow run the application in that environment of not production, pre-production. So they are not being able to build the environment. They are again and again getting dependent on the development team. And the development team is also not very, they do not have that ownership. The process says that they will need to hand over the artifact and the instructions manual to the artifact. In this case is the jar. Jar is the artifact, and the instructions manual, like the deployment steps and all the stuff. Operations team handles installation and configuring apps and its dependencies, and they fail miserably. This is a bottleneck for any project. Installations and configurations done directly on the server's OS. So let that be a server maintained by operations team. They will install it. And dependency version conflicts will arise. This will lead to the confusion and frustration. But after containerization, what happens? After you have, you have done the image, the code was built within as an image and put inside a container. Now you see the configuration, Postgres SQL 15.1, your what was the other thing? Redis, and the startup script. Everything was built inside the container. I mean as an image inside the container. So it's an own isolated environment. This environment will not depend on any other environment. So it is self-running, self-sustained environment. Isn't it nice? You do not need to do anything. For the operations guy, do not need to understand anything. And you will see Docker run the progress. So this entire image can be run over Docker engine. You will be able to start the Docker container using one Docker command. That's all. And the Docker commands are same for all the operating systems. This is a valid and vital point. You see, I do not need to change my command for Linux, for Ubuntu, for Red Hat, for Windows, for Mac. They remain absolutely the same. The command are all same for all the services. So you can see they are smiling, happy. Docker is having their the environment is under control of the Docker. And what about the deployment? Deployment process with containers. It is very simple. So instead of textual or the artifacts and your documents, instruction manuals, everything is packaged inside the Docker artifact. Docker artifact means the image and the container. So the jar file will also be there inside that image. Okay, see, you have one image inside the container. You have the configuration, you have the app source code, which is the Java jar file, and also all the binaries and libraries that are needed to support running of this application. That's all. And you give this image to whom? To the, as an artifact, to the operations team, and the operations team is just going to run that container. That's all it needs to do. No configurations needed on the server, except, yeah, of course, in this server you need to install Docker. In this server you need to install Docker. That's all. And there is very, very little room for errors. Easy to run different versions of the same application without any conflicts. Whether it is Redis 1.4.1, 4.3 or 3.9, doesn't matter. It is very easy and simple to run because you have everything. The configuration is already set within the image, the Docker image. You see, this is the Docker symbol logo. So before containerization, there were problems. The problem was with the environment the code was being run in. Well, a simple answer could be, why not give the same VM to the operations testing or the testing team to run the code? Well, try that VM, but VM is big. You know, the size is too big. It will not be portable to the operations or the testing guys. So what the operations guy is saying, that could, you see, if you give me a VM of say 3 GB, it could break another code on testing or production server, because it is not only your code that is running. So there is a contention of memory. So what will happen to the other programs or other codes which are running in the same server? It can eat up the entire resources. So why do you give a 3 GB code to me? But after containerization, see, this guy is smiling. Oh, of course, not smiling, the same expression. Anyway, but here is the container. It is giving a 30 MB container instead of 3 GB VM. I have wrapped my code in. Yes. Within the container, you have the image, that is the code. Okay, the developer says, wow, it's hardly 30 MB. Awesome. He is very grateful. Your code works just fine. What he did, he took that image and just put that container in the environment. That's all, because the container uh, will not interfere with the environment of other programs which are running, because the entire environment of that container is held within the container itself. So there is no question of contention of the memory of the resources. Any question? I will take a pause. Do you have any questions for me or for your understanding? Or are you finding it a bit boring? Yes. Uh, uh, Initially, anything is a bit boring, but once you get the essence out of it, once you start understanding it properly, then you will find it magical. You will find it. You will enjoy the working with that tool. You will
Sorry,
find it. Yeah.
So you said, why not give, sorry about the noise in the background, why not give the same VM to the operations team? That's a virtual machine.
Yeah. How can you give that same VM? You have
Okay, so
to.
my question is it one container in a is one container the same as one VM, or you can have many containers in a VM?
See, your VM will have the entire OS. So what this developer has to do, developer will he will give the instruction manual. If suppose he has to give the VM to the operations guy, it is not like not like something you pick it up and drop it over there. You cannot do that. So what you have to do, you have to formulate the steps that the operations guy will do it in its own environment. But then the operations guy is not an expert in all this configuration and testing and in tuning up. So what will happen is while he tries to install all the parts and of the VM, that is the OS, the application, and the compiler and everything. So in that step, it might interfere with the already existing environment. So why not I put that into. Let's say I have been given uh, this VM. This VM has to be given to the operations guy. Operations guy. So what will the operations guy will do? They will take the artifacts, the instruction manuals. The instruction manuals are nothing but how do you install this and this and that. So the operations guy will install what are the things? Install OS, install Java. Let's say I'm talking about Java application. Install Apache Tomcat, which is a web server, Apache Tomcat. Okay, and then it has to configure the environment. configure the environment for the entire thing to work as one code. But then while it is trying to build the code as a jar file, see, the jar file has to be again built. Jar file is a Java application archive file. Java application archive file. So once it is going to build into that jar one file, say there are 100 files, 100 Java files. You want to compile them into one jar file. Okay, you have to do it because there are artifacts and there are instruction manual. So that jar file, the build fails because somehow it interferes with the other environments. So there are in this big environment of say pre-production, there are other small environments and maybe one environment clashes. There are several environments which are clashing with that environment of this thing. So why don't I? This is going to take a lot of hardship. There will be a lot of interaction between the development guys, and they will come back and forth. It will go here and there, and finally there will be a lot of confusion. And I know because we have gone through all these things, confusion and frustration. Lot of frustration. Instead, if I do this thing, from my developer, a simple container with an image inside it comes to me or the operations guy. This guy will just in the pre-production server or the testing server, they will let's say this is a testing server. They will simply get that image and run one Docker command. Docker has to be installed. Yeah, Docker installation should be there. There should be a Docker installation over here. Okay, and they will employ one Docker command to build the image and run the container. So the container will be started. When you start the container start. You can stop. You can remove or delete. Because it is like an object. This object is dynamic. And when you start a container, that means you are starting this image. This image is bootstrapped. That means somebody from outside using a browser, HTML browser, where it will give the URL. That URL will be able to access the image running inside the container. That is what we are going to show today. So it is very much important that everything will be there inside this container. I do not need to install anything. Did I install anything? I just got that image and I said, no, sorry, I got that container or whatever the instructions, and I have Docker. So what I did, I just used the Docker command, one Docker command to build, because I got a Docker file. A Docker file will be there. That is the artifact. A Docker file has been given by the developer to me, operations guy, and the operations guy will just know, yeah, maybe the developer has given him the instruction that you please run this command, Docker command. That's all. It will automatically do everything from this file. That's all. Which one was a better process? Do you have to install OS, then the compiler, then the application, or you and finally did not build, or you do it like that? Which one is and this is very lightweight. So since this is very lightweight, like it can be 30 MB only. So you are finding it very convenient. Your life is no longer miserable. You see, if you have a practical experience in any big organization, these operations guys are the most important guys, but they do not have any life. They do not have any social life. They do not have any family life. Their family life is totally skewed. And they do not have a proper sleep. They always are into running for maintenance of the system. But nowadays, your life is, after containerization comes, their life is becoming very smooth. They can enjoy their life, enjoy the family. They can give quality time to their family. So this is all because we are transforming. The applications are transforming. It was monolithic earlier, which was a single layer application. All these functionalities are closely coupled, tightly coupled. It is called tightly coupled. And these are microservices. As we moved from 2000 and today 2024, you will never find these applications. Most of them has migrated or been converted to microservices. These are loosely coupled services, and it is you can isolate them. This is not working. Okay, you just work on this. You do not need to touch any one of them. They are working fine without anything working. Like in e-commerce applications, the e-commerce application is a big application constituted of many microservices, maybe hundreds of them. Yeah, it is a complicated implementation. It's a complicated architecture, but if you can do that, nothing like it. And there is a lot of technology who can support microservices, and people are moving towards microservices. Therefore, you are moving towards containerization. Therefore, you are moving towards Docker. And why Docker in particular? Because there is no competition for Docker at all. There are competing brands like Mesos and Rocket, but they are quite insignificant with respect to Docker. Any question? So you can deploy your applications into many small servers. It is easier to maintain a small server than to maintain a big elephant like a big server. Always. Okay. So your same application is replicated over several. So you will have almost 99.99% availability. This is called resilience, a resilience type of architecture. It will be resilient. That means there will be no downtime. It can keep on going and going. And of course, let's say there is an Amazon application, which is an e-commerce site, Amazon.com or eBay.com, where I'm in India, I'm in the night, I can access eBay, or someone from US can in the morning access eBay. So eBay has to be available 24/7. And that is possible because of the highly resilient microservices. Can you understand the importance of application containerization, which is modernization? If you can go for 12-factor apps, so then you have gone for microservices. This is a single monolithic application. You have modularized it. You have converted that into a microservice. So all these functionalities, the features are as one microservice. Maybe this is the login application. This is the product catalog. Okay, this is the order management. and this on the shopping cart, and this is the payment gateway. But all these are included into one big application called e-commerce application. So they are microservices, break application into separate operations. And this is possible because you can containerize. This application is containerized, one container, one container, one container, one container. This is how you development, you do the testing, and you deploy it to the staging, which is pre-production, or to the production. All will be through some pipeline, automation pipeline. And we have seen certain things which in our previous sessions, like the GitLab, we have created an automation pipeline, and where we have deployed our jobs. We have built our applications, images, Docker images were running. So this is the basic understanding why we should move into containerization. And nowadays, a company cannot, or organization cannot think beyond containerization because that is so overwhelming. So this is a brief history. You must know this name, Solomon Hykes. He was the founder of Docker. Because Linux has paved the way for containerization. So Linux, I will give a lot of credit to, Linus Torvald. Linus Torvald, who has invented Linux. Linux is also a copy of Unix. Unix was actually used in the US defense very early, the 1940s and 50s and 60s. But they were not into commercial use. Only with after Linus Torvald has given Linux to the commercial industry, that all these applications, all DevOps have come into picture. Otherwise, there wouldn't have been DevOps without Linus Torvald. So basically, it was from 2013, better to say 2016. So now it is almost 8 years that Docker is in the market. So it is the right time. It is also a, sort of a baby. It is in the nascent stage. See, a software industry is 100 years old industry. Okay, so don't worry if Docker is only 8 years old. There is an ample scope for you to excel in this domain. So learn these DevOps topics very well. That is, these are the what is Docker. We have that. The isolation, the containers, and all these things are very important features. The Docker architecture, engine architecture, will consist of 3 parts. The components, major components is one Docker server, which we say the Docker D, Docker daemon, or Docker engine, you can say. The REST API, between the client, which is the CLI, and the server is a REST API call. That is also part of the Docker. So when you install Docker, you will install a Docker server, which is the Docker D or the container D. And the REST API will automatically be installed, and the CLI command line, the Docker, where you issue the Docker commands. It is like this. It is this architecture. You will put in the commands over the Docker CLI. We will see that. And then the Docker commands will go to the Docker daemon through the REST API. There is a REST API call from the CLI to the Docker daemon, because this daemon is working in the background, in the backend. What will this daemon do? This will manage your data volumes, your image, your container, your network. So Docker network, Docker container, Docker images, and Docker volumes, the data volumes will be all managed through the Docker daemon. But you are issuing the command from your Docker CLI. Any question that you may have at this point? Before I go to the hands-on, if you have any questions. No question. No question is also good, and no question can also be not that good, because to me it may appear that you are understanding everything if you are not asking, or you may not understand anything. So two things can happen. But I believe, as because you have spent your time on a Saturday morning or a Saturday evening, I think you are the best guys. So a best guy uh, always understands the topic. Thank you. So basically, the Docker workflow is on the CLI, on the client, which is part of the Docker. You see, this is part of the Docker installation. That CLI, like you will give the Docker commands over the CLI, and then it will be taken to the Docker host, which is the Docker engine. Through what? Through the REST API. The Docker daemon will interpret the REST API calls for the Docker commands. And the Docker daemon, the Docker D or the container D, will then work with the manage the images, it can put that image into a container and run the container or stop the container. What is this image? This is nothing but Ubuntu. So where it is? It is in the Docker Hub. So all these things are related. You are pulling an image from the Docker Hub, which is already there. You are pulling it. This is Redis. This is Nginx. This is, I think, CentOS, another Linux. So you can pull any of these images from the Docker registry, which is a Docker Hub. This will come down to your local repository as an image in the local repository. And from that Docker, with one single command, you can put that image into a container. So you say that you have containerized this image, this Ubuntu image. And once you have containerized, you can go inside the container through one Docker command and can manipulate. You can install on top of Ubuntu another software called Java, maybe, or any web Apache server. Okay, so you have to get that image into the container, containerize it, then get inside the container and do it. So I will not go further onto this because we need to do some hands-on. I hope you will understand. These are the various Docker components like Docker Hub, Docker Engine, Docker Images, Docker Containers, Docker Volumes, and Docker File. We are going to use a Docker file, that is, whatever the Docker CLI commands that you write, you put that into a Docker file. Like you write the shell scripts. What are the shell scripts? Shell scripts are nothing but the shell commands that you compile them into one single script, such that when you run the script, from the top to the bottom, each line of the code within the file will be executed one after the other. Similarly, if you want to do it the same thing, instead of writing the manually all the Docker commands, you put them into a Docker file and you just run that file. That is what we are going to do. So these are the things. We are going to do a hands-on. So before I go to the hands-on, if I may ask you whether you have any questions. It's a time for questions, if you have any. Or shall I proceed? Let's proceed. Why you are so quiet today? Is anything drastic has happened? Or is it too much? on a Saturday evening or a morning?
Yeah, guys, you can suggest us. If it is too much, we can pause today's session and we can
We can
resume
stop.
from,
Yeah,
yeah, we
yeah,
can resume from the next weekend. Because the main objective is
yeah.
you should learn and you should know the stuff. You should not be overpouring.
It should not be. It should not. I have no intention to bore you with lots of information. This is just awareness program. You see, you will get to know that okay, I need to understand Docker a bit more. Docker is so important. I need to, because this is what we are going to work. This is a technology that is what we are going to work in our job area, in our job as a DevOps engineer. So I have no intention to spoil your Saturday evening or a morning. If you want me to continue, I will. Or if you don't want me to continue, I will just stop the and there's no harm. There's no hard feeling. We will continue to on the next weekend. It's up to you.
Then maybe we can continue from the next weekend. Because today I think we made them a
Yeah,
little
yeah,
bit
yeah. No problem,
overcooked.
no problem. I have no issues. But at least if you can tell me that Devashish, you are too boring, I will accept that. I will accept that. Because the subject, if you have to go and learn the subject, you have to pass through that phase. Okay, I give it to you. Let's continue in the next session. What do you say, Mr. Menon?
I think that will be good.
Yeah, because if I start the hands-on, you might not be in tune. So you will get a 1 week's time. You can go through this contents which is available in our site so that you can better prepare yourself for the next session. We will have the hands-on.
Or if you all agree to we should continue, we can continue. So, but for that, please speak, or or else there is no point. So we could continue.
This is up to you. I have no problem. See, I will be again available next weekend. You have to bear my bear me. Even if you don't like me, you have to. Yeah. So it is up to you. You tell me, I will.
I think okay then.
Okay.
Then we are going to continue this Docker session, the rest of the session tomorrow, next weekend, and
Next weekend, we will complete this hands-on. And from next to that next weekend, we'll be starting the Kubernetes. Because
okay,
unless you know Docker, you will not be able to understand Kubernetes.
makes sense. Perfect.
Yes.
Okay then.
Sure.
So we are going to we are wrapping up our today's session. So anyone have any other question? Feel free to ask, or we are going to close today's session.
So